Okay. All right, so if you have your notes out, you have a periodic table out, you got a calculator out, I'd like to teach for only about 20, 25 minutes, and then you'll have a chance to work on your certification, and then you'll have Monday to work on that. You'll have Tuesday to work on your homework, Wednesday to work on your homework, okay? Okay, gotta wait till everybody's ready. All right, hold it. Shh. Wait a minute. Everybody's not ready. Notes, calculator, notes, calculator. All right, if you have a periodic table, get a periodic table out. You know, if I was your band teacher and you sat there and you said instrument, I had to get my instrument out? No, you wouldn't do that. If I was your baseball coach, you said, baseball glove? I'm supposed to bring my baseball glove? No, not. And yet, some of you take chemistry class said, my notes, calculator, what? It's the same thing. I used to coach a lot of sports, and sometimes you have somebody would come to soccer practice, they didn't have a ball. Like, okay, I had extra balls, but they should bring their ball to soccer practice, don't you think? Okay. All right, ready? Look up here. All right. Now, when I review, this is what some of you don't understand. Review is not boring time. Review is where you said, I fill in the holes that I had. Yeah, I thought I knew how to do this, but now I really know how to do it. Let's take a look. One of the problems I gave you, I said there was a chemical, and we talked about alcohol, and this is ethanol. Ethanol is a type of alcohol, and it's C2H6O. One of the things chemists had to do at one time to figure out what matter was made of, they had to do a percent composition by mass. So, remember how we talked about you could do this in a little world? That could stand for 1 molecule of ethanol. What else could it stand for? Starts with M. In the big world, that could stand for 1 what? Mole. If that's 1 mole of ethanol, it's made of 2 moles of carbon atoms, 6 moles of hydrogen atoms, and 1 mole of oxygen atoms. So let's take a look. Ready? What's the key to percent? You always divide by the total. Yes? Okay, here we go. Now the total is, ready? 2 times 12, carbon's 12, right? 2 times 12, 6 times 1, 1 times 16. So the total is 46, isn't it? So everybody's going to be divided by 46. What percent of the 46, how much of the 46 was because of carbon? 2 times 12, 24 divided by 46 is 0.521. That's 52.1%. How much is due to hydrogen? Only 6 out of 46. Does everybody see how it works? I keep looking at you because I can't tell what this means. I can't tell. If you don't have this already written down, don't you think it should be written down somewhere? Now, another thing you should do when you do percent composition, you should add these up. So take your calculator, and if this isn't close to 100, we probably made a mistake. See if it's close to 100. Do you have a calculator? Do you have a calculator? Can you make sure you get back to me?
Yeah.
Okay. Be careful on the test, because what if 4 people don't have a calculator and I only have 2? That's going to be a problem, isn't it? Yes. All right. Is everybody okay on this? Now, take a look. The harder problem is this, and one of the certification problems is like this. One of the certification asks you, find the percent composition of one of the elements. And then it says, I'm going to give you 300 grams of that. So what if I give you 300 grams of ethanol? How many grams would be carbon? Now here's where you have to think. Any amount of ethanol. A drop of ethanol is what percent carbon?
52.
See? A swimming pool of ethanol is what? 52.1% carbon, isn't it? So what if I give you 300 grams of ethanol? How do I find 52.1% of that? And your math teacher should have taught you this. When you want to multiply by percent, you have to change it back into the decimal, don't you? 0.531. Now, if you put that in your calculator, all right, I already know what the estimate is. What's about half of this? 150, right? It's going to be a little more than 150, isn't it? So put that in the calculator. What do you get? Did everybody get 156? Okay. So the first thing chemists had, hey, I know how many grams of carbon are in that because of percent composition. Okay, you okay on that? This is review. It's not the first time you heard it. It should be the second time, maybe third. Now, the next thing we did is chemists said, I'm glad I know how many grams of there are, but now I want to know what's the formula. And so when they do an analysis, they can only come up with it called the empirical formula to begin with. I always ask this question on the test. The empirical formula is the what? It's the lowest, what is it? Whole number ratio of the elements in there. Now these are real chemical formulas. See that? But are they reduced? Some of them are. Can you reduce H2O? No. So the empirical formula for water is also H2O. What about glucose, C6H12O6? What's the empirical? Very good. And what about hydrogen peroxide? Very good. See, you'll eat those kind of questions up, won't you? You should eat those up. And what about C6H12? CH2? Okay. And now, another thing I want to tell you that ionic compounds are actually ions, and ionic compounds are already the lowest whole number ratio. So I already know that ionic compounds are always they're also the empirical formula too. So I don't have to worry about these are all non-metal. Aren't these molecules? A lot of molecules can be reduced, but none of the ionic compounds can be reduced. All right, yeah, okay? Let's review. Okay, so we'll get rid of that. All right, next one. We had a problem, and I forgot to write the page number down, but they said I had this many grams of aluminum, and they knew that it combined with this many grams of oxygen. Everybody got that? Okay. So now, they want me to find the empirical formula. Now, this is what some of you are going to forget. Hey, Matthew, can you close that door for me, please? I'll wait till you get back. All right, so let's say somebody asks you to find the empirical formula, but I want you to look right here. Look at what I'm doing here. If anybody asks you for any kind of formula, you can't do it in the gram world. This has nothing to do with grams. This says 2 particles of hydrogen are combined with one of those. Now, what 4-letter word means you're in the world of number of particles? Moles. So they're going to give me the grams of each element. I cannot find a formula in the gram world. So what do I have to convert to? And we've done that a lot. You've got to get out of grams and into moles. Now, if you have to still write the 3 equivalents, that's okay. Write them down. How do you change grams of aluminum to moles of aluminum? There we go. Is everybody okay on that? There's no way you're going to do it well in the test if you can't do something like that. Okay, now, look at the number I got. 0.154. Ugly. That's an ugly number. Now let's go down here with oxygen. Okay. Ugly. Okay, now, what happens if the empirical formula is the lowest whole number ratio? Do these look like whole numbers to you? No. So there was a math trick. They've known it for over 1,000 years. How do you make ugly numbers turn into closer to whole number ratios? Hey, I got everybody how to listen, okay? Okay. When you're reviewing and you're not paying attention, when we start the certification, you'll be having your hand up. I don't know how to do that one. I don't know how to do that one. See? I'll say, get your notes out. I didn't take notes. I didn't take notes. I said, what do you want me to do? What do you want me to do? What do you want me to do? Okay, ready? Now, how do we fix the ugly numbers thing here? We divide by the smaller of the 2 numbers. So what's 0.154 divided by 0.154? Ooh, that looks nice. And what's 0.231 divided by 0.154? It's actually 1.5. Now, I know that we're almost there. They're almost whole numbers, right? What can I do to the number 1.5 to get a whole number? Multiply by 2. What if it had been 1.33, 1 1/3. By what? 3. What if it had been 1 2/3? You multiply by the denominator, right? Well, anyway, I probably won't give that to you. I'll probably give you the halves. Anyway, if you multiply this number times 2, you have to multiply this times 2 to keep the ratios the same. And lo and behold, we're finished because it says, and chemists were glad about this. They say, I found it. Aluminum oxide is 2 pieces of aluminum for every what? 3 pieces of oxygen. And finally, they know the formula for aluminum oxide. Now, you guys know it because I just taught you how to name compounds, how to put compounds together. But they didn't know that at one time. Are you okay with this? Okay, let's look at another one. I might have one more. Here is remember the vanadium problem? Okay. So here, they made a little trick here, but not really. They said, this is how much vanadium I had. And then they said they heated it in air, and it got heavier. And that wasn't that number, it was another number. So what if you weighed 2 grams, and I heat you in air, and you weigh 2.5 grams? Then why do you weigh 2.5 grams? You must have combined with how much oxygen? Hey, you better look at me again. If I start with 2 grams of vanadium and I heat it in air, and all of a sudden it gets heavier, like 2.5 grams, why is it heavier? Oxygen. So how much oxygen was there? It started at 2, it ends up being 0.5 grams of oxygen. And that's what this problem was about. So we had to subtract to find this number here. Now I'm asking about thinking. We're thinking, aren't we? Okay, now, guess what? I have grams of vanadium, I have grams of oxygen. That's just like the problem we did. You can't stay in the gram world. What do you have to do to get an empirical formula? Go into the mole world. And again, we've done it over and over and over. Now, ready? Here's ugly number 1, 0.00695. These are not significant, so you go 1, 2, 3 sig figs. 0.0174, another ugly number. How do we get ugly numbers not to look so ugly? Divide by the smaller of the two. This comes out to be 1. This comes out to be 2.5. Well, how are we going to fix that? We're almost there, aren't we?
Times by 2.
Not divide. What do you say? Multiply by 2. And this comes out to be 5, 2. And you know what? The chemists are glad because, hey, this vanadium oxide is V2O5. And this is how chemistry got its start. The mole concept helped greatly. It helped a great amount. Okay, I don't think I'm going to do another one. This is another one in the book for lead. Okay, I don't want to do that one. All right, so I'm going to show you 2 more things. 2 more things. Here we go. Now, on this page here, again, even though I'd like you to bring your book, I do have a camera. Luckily, the school has document cameras, and I love those. And so what I'll do is I'll try to make this big enough for you to see. All right, here we go. A white powder was analyzed to find and found to have the empirical formula P2O5. Well, you're going to give me the empirical formula. I don't have to figure it out? Thanks. That's one thing I don't have to do. But then what does it say? Another test was done, and they found out that the molar mass, what's molar mass?
How much it weighs.
How much weighs? Molar mass is the mass of how much? 1 mole in grams, isn't it? So another test said, hey, the real chemical has a molar mass of 283.8. Is this the real chemical? Is your empirical formula the real one or not? You say, how am I supposed to know? Okay, here's what I want you to do right now. Take your calculators and your periodic table. How much does this weigh? How much did the empirical formula weigh? So do that right now. Find out how much the empirical formula weighs. Now again, you're getting ready to be certified, and if you can't go in the calculator and say 2 times phosphorus, where's phosphorus? 2 times 31, 2 times 31, 5 times 16. So how much does this P2O5 weigh? Everybody get 142? Okay, now watch now. These are the kind of problems you love. The empirical formula weighed 142. Is that the real chemical? You say, I don't know. How am I supposed to know? Well, another test was done that said the real chemical has a weight of how much? So it can't be. What am I supposed to do about that? How much does it weigh? 283. How much does yours weigh? How many times does 142 go into that? 2. All you have to do is take your empirical formula and multiply everything times 2, and you'll get the right number. So what's the real chemicals formula? Let's try it again. I took this right here. I divided it by the mass of this empirical formula, and it said you need 2 of those. See that? So multiply everything here by 2, and what's the final answer? P4O10. It's amazing. All right, we're going to do one more of these just to make sure you understand how to do it, all right? Everybody see how I did that? So what is the real chemical? P4O10. What is the empirical formula of P4O10? Remember reduce? And that's what they told us, didn't it? And matter of fact, if you added all these up, if you add up all these weights, you know what you're going to get? 283. I did it. Okay, so now, whoever you sit next to, here's what I'm going to do. Ready? Now, this is crucial. Who you're sitting next to, you're going to try this problem right here. Now, if you, I'm going to show you one more trick. I'm going to show you one more little trick in chemistry, and then if you guys can do this problem here, you're essentially done, and then you can start certified. Okay? So let me show you one more trick. I remember when I first saw these, I didn't understand what the teacher meant, and I'll try to make sure that you do understand. Do you see this right here? Somebody did an analysis, and they found out that this compound is that percent chlorine, that percent carbon, that percent hydrogen. And I have to get an empirical formula. Well, I can't do it from the world of percent. I got to get in the world of moles. But how do I go percent to moles? Okay, so here's what we're going to do. Ready? Let me show you something. How much of this stuff did they give me anyway? No, they didn't. They said that another test said that a mole of that would weigh 98. I don't know if they gave me a mole. But let me ask you this question. What if they gave me a huge amount of this material? What percent of it would be chlorine?
7.
Okay, what if they gave me a little bit of material?
7.
Okay, so I could pick whatever I want. I can pick whatever amount I want. You know what I'm pick? I'm going to assume they gave me 100 grams. Why would you do that? I'll tell you why. What is 71.65% of 100 grams? 71.65 grams.
Wow.
Pretty smart, honey. So guess what? If I see a problem like this, I just change that to grams. I'm just assume they gave me a 100-gram sample and 71.65% of 100 grams. So how do you start the problem? 71.65 grams of chlorine. And what am I going to do now? I got grams of chlorine, I got grams of carbon, I got grams of hydrogen. What am I going to do now? Yes. Now, why are we putting in moles? Why? Because what do I eventually want? I have to get into formulas, right? Formulas in the world of moles, right? So I'm in grams, change grams to moles, and do what I just did. All right, sit with somebody. It'll probably take you about 5 minutes because you'll have a little problem with this. And I'm going to write this out on paper, and by the time you're done, I'll be done, okay? Go sit with somebody, okay? I don't want you to do it by yourself. Well, what you really want to do is change all the percents to grams, and then change grams to moles. Okay? Once you get in the mole world, you'll have these ugly looking numbers at you. What are you going to do with those ugly numbers? You're going to divide by the smallest.
Yeah.
And then you're going to get some nice looking numbers. That's going to be the empirical formula, isn't it? And then you're going to see whether or not the empirical formula happens to be the same chemical. Maybe, maybe not.
So we don't put it in.
No, I wouldn't put citrate. No, I wouldn't. Does everybody know that chlorine is 35.5? It's not 35. Does everybody know what 3 sig figs means? Now, I don't know if you understand what I'm doing here, but you have to think your way through these problems, but you understand them. If you do them over and over, you understand them well enough. All right, is everybody done with the moles? Is everybody done with moles yet or not? Okay, now let's say you're not done. Look up here. Here's how you do it. I assume they gave me a 100-gram sample, so all of a sudden 71.65% becomes 71.65 grams of chlorine. And then when I, remember the 3 equivalents? If your neighbor, if your partner is doing the wrong 3 equivalents, correct them. Now, did everybody get 2.01 moles? Did everybody get 2.02 moles of carbon? 3 sig figs. Is this a 2? Okay. Okay, sorry. And then if everybody gets something like 4.07 for the last one? Okay, now, even though these are close enough to whole numbers, I could do that. Let's just go ahead and divide by the smallest of the 2, just so we get in the habit of doing that. Does everybody know how to do this step? You divide by the smallest? Yeah. What are you going to get here? 1. 1. Yeah. Yeah. Now, I don't really care what order you put them in. I know more chemistry than you, but I know the normal order of this. I don't really care which order, but what it says here, for every 1 chlorine, you should have 1 carbon and how many hydrogens? Is everybody there? This is called the, what formula? What's the name of this? No, not epilepsy. No, not epilepsy is a disease. Empirical, it's called the empirical formula. You guys are funny. You're funny. Okay. Now, does everybody have the empirical formula? Yeah. All right. Now, the next question is the real chemical CH2Cl? Well, let's take a look. The real chemical, a mole that weighs how much? Well, let's find out how much yours weighs. How much does your empirical formula weigh? How much does it weigh? Okay, does everybody know how to do that? You got one of these, that's 12, plus 2, that's 14, 35.5. Chlorine's 35.5. How much is it? 49.5. Okay, now, is this the real chemical? No, it can't be. So, what do we do? What's that number again? 98.96. How many times will yours go into that? 2. Yes? So I don't need one of these. I need to double everything, don't I? So what's the final answer? Go ahead. C2H4. I'm telling you, I'm so proud of you for doing these. And I'm hoping that you're not sitting back there and said, I didn't even know how to change it to moles. I'll help you, but we've done this so many times. You just have to suck it up and say, I need to come in for help because I can't even change grams into moles. You'll never be successful in that test. You have till Thursday to be ready. That's plenty of time. Now, I've taught everything in the chapter, everything. I'm going to give you back your certification. Let's talk about the rules. Let's talk about the, what now? Okay, we're fine. Okay, wait a minute. Here's what I do then. I'll give you your homework sheet. It's not even due till Thursday. Okay? So you can work on that for a little bit, and then tomorrow, Monday, all day Tuesday, certification.
Yeah, I like that.
Certification is like a practice test. Then on Wednesday, I'll let you sit in groups and work on your practice test, and you'll be really, really ready. What do you think? Can we do it? This is going to be the last big grade I can give. Y'all have one more week, but you might have a little bit. But you don't have any. You won't have any big major grades. All right, let me get that for you.
Summer coach.